This is a revision video for electromagnetism. This is applicable to foundation, higher and triple students. Electro means electricity, magnetism means magnetism. So how are electricity and magnetism linked together? Well, if we draw a simple wire, and if I draw an arrow on it to represent current, if we have current in a wire, we generate a magnetic field. And we can use our right hand to demonstrate and see which way the magnetic fields are. So we put our right hand in this grip position and then point our thumb in the direction of the current. The direction of my fingers show the way the magnetic fields are. So in this case, thumb pointing that way and my fingers are curling this way. So the magnetic field is in this direction, around the wire. It's only a small magnetic field for a straight wire, but we can increase the magnetic field if we turn it into a coil, and we call that a solenoid. So if we get a straight wire and I wrap it into a coil, that type of shape, that is called a solenoid, and that increases the strength of the magnetic field, but we still have to have a current flowing through the wire, even the solenoid shape. So the solenoid shape is increased strength of the magnetic field, and we can increase this further and turn it and make an electromagnet by giving it a magnetic core. So for example, we could use an iron nail or an iron bar. We could use anything made out of steel, anything made out of cobalt, anything made out of iron, or anything made out of nickel. Any material that is an induced magnet skin. So we get our magnetic core, we wrap a wire around it, so the coil or the solenoid, whichever way you want to call it, and then we need to have current. And if we turn the current on, it turns the electromagnet on. If we turn the current off, it turns the electromagnet off. And if we bring a induced magnetic material close enough, it will attract. So for example, if we bring a paper clip close to an electromagnet, paper clip's made out of steel, the paper clip will attract. So that's how we can make an electromagnet. And we can increase the strength of an electromagnet by increasing the current. That will make it stronger. Increase the current. If we increase the strength of the magnetic core, we make the electromagnet stronger. If we have more turns on the coil, we increase strength in the electromagnet. And also if we wrap the turns tighter together, if the turns are tighter, we also get an increased strength of an electromagnet. The magnetic field lines for an electromagnet, for a solenoid, are very, very similar to a bar magnet. So if I was to draw the solenoid again, one pole is going to end up being north, one pole is going to end up south, and again they always go north to south. Always go north to south in the same shape as for a bar magnet. The key thing is it's always north to south. And for triple only students, you need to be able to explain how electromagnetic devices work. For example, if you've got an electromagnet attached to a circuit, put a switch in it, and let's have an iron bar there. When we close this circuit, we get a flow of current, the electromagnet will turn on and it will attract the iron bar. So that explains how that circuit works. So there's many different examples they could use. Look carefully at the circuit. The key thing to remember is turning the current on generates a magnetic field, turns the electromagnet on, electromagnet will attract. Then you have to look at the other parts of the picture to see what's happening